Hi, my name is Roy Swonger, and I'm Senior Director and Product Manager for Database Upgrade and Utilities here at Oracle. This video will show you how to migrate a database 11.203 or later up to the Oracle Cloud using the Full Transportable Export Import feature. Full Transportable Export Import is a feature we added in Oracle Database 12c, but actually the export side was added in the 11.203 patch set, which is why you can use it to migrate from 11.203 or 11.204 up to Oracle Database 12c. In this case, we will take a non-CDB, which all 11G databases are, and migrate it into a pluggable database, or PDB, in the Oracle Cloud. So let's get started. The first step in this migration is going to be to take a look at the source database to determine what we need to do in order to perform this transportable export and import using the full transportable feature. So we have our Oracle SID of FTEX, which is short for Full Transportable Export in this case. We'll go into SQL+ and format some outputs so that we can look at what is in this database and some of the important things such as character set and time zone that are important when you're performing a transportable tablespace type of migration. One thing that's always useful to know is what components are in your database, what amount of data you have to export and import. So we'll take a look at the components in this database, and you'll see that it is basically the standard example database with a bunch of components. We have removed a few, but it's got a pretty healthy component list. Everything's at 11.204, and all the components are in a valid state. We have several users, including the typical Scott and sales history SH schemas in here, and that's primarily what we're going to be moving in the user table spaces. Then we'll look at the time zone setting for this database. Because transportable tablespaces will not modify the data in the time zone data files, we need to make sure that the source and target time zones are the same in case there are timestamp with time zone and timestamp with local time zone data in the database. We'll also look at the character sets to make sure that our character set lines up, again because the character set used within the tablespace data files for the source has to match the character set in the target database. We will now connect to our cloud environment using SSH. I will blur out the IP addresses and such here just for security purposes, but Secure Shell is the way to connect to your cloud environment. We'll then take a look at the cloud database to make sure that all of those important characteristics line up with our source database. Remember, the cloud is going to be a Linux database. In this case, I'm going to create a pluggable database to connect to. So we use the create pluggable database command. We have to specify our admin user credentials. And you'll notice that this is a very fast command. We're actually provisioning a new pluggable database here. It will finish in a matter of seconds, much faster than if you did something like dbca or a create db type of script from SQL+. This is all being done in real time, so we're not compressing time in this clip or anything like that. And by the time I finish talking here, the pluggable database will be created. So there you go. We have a pluggable database that we can import into. I almost said ready for import, but we're not sure of that yet. So let's go take a look at some of the characteristics of this PDB. So we alter our session to set our context to be within that pluggable database container. We'll start it up, which will happen very quickly. And then we're going to look at the time zone and the character set of the pluggable database to make sure that they match our source database. One of the things that we will need for a data pump import is a directory object from which we will read our dump files. So we'll create a directory object in our cloud environment. The cloud uses the typical /u01 type of directory structure, so I'm creating a staging directory there. And we have to grant our access to that staging directory to the system user. We will use the system user for our imports and exports. It's always a good idea to use system, not sys. You really don't want to use sys for anything that doesn't require that very highest elevation of privileges. We're altering the default table space for this database because we're dropping the user table space. Your default PDB will have a user's table space in it, and in this case we're going to bring in the user's table space from our source database. In order to drop that table space, we had to alter the default table space for users in this database, and we've done that and dropped the user's table space. Now we're looking at the time zone here for our target database, and notice it does not match the time zone for our source database. So we're going to need to alter that. It's a pretty simple alter database command, so we alter our time zone setting for the database, and then we will have to restart our PDB in order for that time zone setting to take effect. So this is just a quick alter and then a stop and start of that PDB. And there's your evidence that I'm actually typing this live because I had a typo on the exit command. We'll now switch back to the source database and we'll perform a few other queries there to check it out. As you can see, I'm going to be looking at the directory objects defined in this database. Because I have used this database before, it actually has a directory object that I can use for data pump exports. And we're just going to check on that to make sure that the directory path and directory name are what we expect. It's going to be the /cloud directory, and as you can see, it's in my temp directory on my source database. So it's the same directory object name on source and target to cloud, but it's in a different location on my file system in each case. We can now look at our parameter file to show you what is needed in order to perform a full transportable export import. The keys will be the full equals y, transportable equal always, and version equal 12 parameters. Those three parameters working together in an 11204 database are what invoke full transportable mode, as opposed to a regular data pump export or a normal transportable tablespace export. If you're going from a version 12 database, you would not need the version equal 12 there. The next step in order to perform our export is to set the user table spaces to be read-only. In this case, it's not just users, but also the example schema's table space. We set them to be read-only, but we leave the database up and running. That's necessary for a data pump export. And we can copy those table space data files to the staging directory. So we're going to take our users table space and our example table space and move them to the staging directory that I used for the directory object. So there you see the full size of our tablespace data files, the examples one being much larger than the users one. At this point, I'm going to zip the files for upload. And the reason for that is that generally a network transfer is going to be your bottleneck when you're migrating to the cloud. Even with really good network throughput, you can generally save a lot of time by compressing a file before shipping it up there and then decompressing it. The compression and decompression will save you lots of network transfer time, much more than it takes to actually perform those operations. So after the compression, you'll find that those tablespace data files compress very well, a factor of 5 or 10 to 1 in this case. At this point, we will perform the data pump export using that parameter file that we looked at. So this will be a full transportable export. And what this will do is use data pump to get all of the metadata from the database, but move the data in those tablespace data files. Now, in this case, with the example database being fairly small, moving the data as part of a regular data pump export would be trivial. But if you had a larger database where the size of the data absolutely dominates the size of the metadata, then using full transportable could save you a great deal of time on your export and import operations. Of course, you still need to move the data up to the cloud by copying the data files or the dump files. But full transportable gives you the best of both worlds using data pump, as you see here, a very familiar view of a data pump export for the metadata, and using transportable tablespace for the data without all the complexity that is usually associated with a transportable tablespace migration. In this case, with the sample schemas, it's going to take us just a couple of minutes to perform the full transportable export because all we are getting is that metadata. You see all the different types of metadata being exported here, everything from synonyms to tables to grants and so on, all in the proper order that is needed to produce a full set of dump files. When you see us exporting the contents of tables, which will happen, the reason we're doing that is that full transportable export import gets some of the extended metadata that Oracle will produce for some of our components. And it can even get user tables that are stored in the system tablespace, for example. It's never a good idea to store user data in the system or sysaux tablespace, but sometimes people have done that historically. And we can get that using a conventional export. But what you see here is a bunch of Oracle-related tables, not a lot of data in them, but we will get that data out of your system and sysaux tablespaces when needed. So now we have our dump file, and we will be ready to upload our data to the cloud. The one point I did want to make is you do see two errors here about an index not supported. That's because particular types of tables with domain indexes, we don't get those domain indexes. That is a perfectly normal and expected error in this case. I will occasionally clear the screen like this just so that if I am going to use SSH or SCP or anything where I'm putting in security information, I don't have to blur out the video for extended periods of time. And the next command here is an SCP command. This will move my my dump file from my local system up to the cloud, again blurring out the IP address and such. And then I will also move the database, the data files for our user table spaces using SCP. The dump file itself will take, I don't know, a minute or so to move up there. And this is an area where I will speed up time because watching dump files upload is akin to watching grass grow, but you will see the full duration once each operation completes. You can also see that the bandwidth that I get internally here in our network up to the Oracle Cloud is perhaps less than what you would see externally. We do throttle our bandwidth internally to optimize the bandwidth available for customers. So I'm probably not going to see more than about 100 kilobit per second, or kilobyte per second, excuse me, but you may indeed get much better bandwidth than that if you have a good network externally from your organization. And you'll also see that these are the commands that I am pasting instead of typing in by hand. As you can imagine, trying to type that kind of SCP command with all the tildes and punctuation and IP addresses can be a bit error prone if you do it manually, and I didn't think you wanted to see me make a bunch of typing mistakes. While that file is uploading, I can go and look in the staging directory on the target system. Now, another thing I could mention is if you had a more extended amount of time that would be needed for your metadata export, like say you had a large application database with hundreds of thousands of objects in the dictionary, you could actually start uploading the data files for the table spaces while you were doing the export, because those table space data files were already put in a staging directory, and in fact the table spaces were read-only anyway. I did that serially just to make the process a little bit cleaner as we go through it. But we look up in the cloud environment, We see that the example data file is still uploading. The user's data file and the dump file are already there. We can look at the par file, and you see it's a very simple parameter file. All we have to do is tell it the dump file, log file, and the list of data files that we're going to import for our transportable operation. Once we've done that, we just wait for our upload to complete. Again, I have compressed time in this section of the clip just because this upload takes about 3 or 4 minutes, and there's only so much you can say about uploading a file. Okay, now that that's done, as you can see, that file took 3.5 minutes to upload for 22 megabytes, which would have expanded to about 5 or 10 times that on disk. If you have a much larger database, like hundreds of gigabytes or terabytes, you just plan on taking some downtime to do that. Or you could use a technique such as data guard with a physical standby to move up to the cloud and eliminate that downtime. We unzip the files on the target system. That goes very quickly. That was real time for that unzip of each of those data files. And then we will perform the full transportable import. It's a very simple command because we've put all of our parameters into the parameter file. It's always advisable to use a parameter file because your list of data files may get fairly extensive, and the quoting in a parameter file is much easier than trying to do the quotes and escape characters on the command line. So we will now perform this import of our full transportable import. That will go get the metadata from the data file and hook the dump files, get the metadata from the dump file and hook the data files into the database. Because this is an 11G database, just like any data pump import, full import, you're going to get a lot of these already exists errors, as we call them. And that's because up until about 12.1, data pump export wasn't that smart about skipping objects on the export side that we knew would exist in a destination database. If you're coming from a 12.1 database, you won't see those errors there because starting with 12.1, data pump export will look at an object like this global AQ client DB context and say, hey, any 12C database is going to have that object there. I'm not even going to bother exporting it. But this being an 11.204 database, the export side wasn't quite as intelligent as it is in 12.1. And that's one of those little enhancements that we make that don't really get elevated to the sense of a new feature, but will provide you a little quality of life improvement once you're using data pump in 12.1. So now we've imported some of those tables of data that contain extended metadata for the Oracle database. We'll look back through some of these errors. There was one here where we had an object that failed to create because this is not allowed in a pluggable database. In this case, that means that that object exists in the CDB root already, so we're not creating it as a common object in the pluggable database. As we go through the rest of the import, we're going to do things like import the indexes. That's an area where a full transportable export import will save you a lot of time if you have indexes, because all we have to do is hook the indexes into the database instead of building the indexes, because the indexes themselves exist in your tablespace data files. So if you have something like an eBusiness Suite database, an SAP database, JD Edwards, and so on, any of those applications that has hundreds or thousands of tables with thousands of indexes, Transportable Tablespaces can save you a great deal of time because we don't have to rebuild those indexes. These import callouts are kind of interesting. What we've done, and one of the reasons that full transportable export import works so well, is that our import will do things for our Oracle supplied components through these callout mechanisms that are necessary to fix things up afterwards. So we really get a robust set of metadata for all of our components. And you can see we had 395 of these already exists errors. They're fairly benign because that just means that the object that we were trying to create already exists in the target database. After the import, the database is open and it is read-write. We can show this by connecting to our container database. You see that the PDB is read-write. It's not restricted. We can go over and take a look at it, see whether we can poke around our newly imported pluggable database and make sure that the data we expect to be there is there. So let's go look at the good old scott.emp table and how many rows are there, just as a for instance. And what you'll find is the typical 14 rows of data, so everything's done. So what you've seen here is the full transportable export import of a database from a non-CDB 11.204 up to the Oracle Cloud into a pluggable database 12.102. So what we've accomplished is migrating a database from on-premises up to the cloud and performing an upgrade all in the span of about 20 minutes. I hope this has been helpful, and if you have any comments, please send them along and I'll respond as best I can. Thanks a lot.